production data into the cloud. DMS provides a graceful switchover capability. Now that I've given you a quick update on SCT and DMS, I want to talk about how you manage a migration project. One of the most important things to consider when evaluating an application is whether there is a business driver and ROI that justifies the migration. If you don't have this defined, then it's going to be hard to get all the different teams on board and make that migration successful. A typical one would be the application needs a complete hardware and software stack update together with new revenue increasing features. Therefore, by upgrading, you are removing business risk by getting off of unsupported platforms while increasing revenue opportunities. Once you have that defined, you'll need a migration sponsor, such as the application's business owner or even a C-level. This is critical when you need someone to break through barriers and bring teams together. If your application is from an independent software vendor and therefore you don't control the source code, then you need to check with your ISV on what database options they support. We are seeing more and more ISVs provide options for open source databases and even native AWS databases such as Amazon Aurora. The maintenance window for the migration will decide on the fundamental approach of the migration project. If you have a short duration of less than 15 minutes, then you will most likely have to use DMS with CDC to keep the outage as short as possible. However, if you have a whole weekend, then a simple export and import using native database tools like MySQL dump may be good enough for a homogeneous migration, or text unload and load tools for heterogeneous migrations. If you still have access to the design documentation and it's up to date, then that can help new team members get up to speed quickly and make better decisions on how to migrate the application system, including integration points. If the original developers and DBAs are still available, then they can provide valuable input on the application and database, such as what modules and tables are no longer used and don't need to be part of the migration. SCT will help you with most of the items on this slide, but time zones, authentication, and especially licensing mechanisms will be something that the migration team needs to consider. Data types such as numbers and strings are normally straightforward to migrate from one database to another. But LOBs and special data types like spatial data will require more care. The application can be relatively simple to migrate to another database if it supports a framework that allows data store changes with a configuration change. However, older applications often have complex business logic and store procedures or SQL statements throughout the code. As a general guide, the higher the level of abstraction away from the database, the less work will be needed at the application tier. If the SQL is ANSI compliant and focuses on simple CRUD operations, then the migration effort should be manageable too. However, if the SQL is primarily for complex reports or OLAP operations with many joins and database functions, then more work will be needed. How the application accesses the database can also hinder migration. For example, if you have to allow access to an LDAP directory, then the security team might have a long time to get approvals of how that will be managed from AWS to on-premises. You will need a few key people on your migration project. The first is an application architect or lead developer who understands the application deeply and can guide the team on what components are important, complex, redundant, etc. The DBA for the source system should know the database design, schema, features used, and what must be migrated to the target database. The DBA for the target database might have to be someone that you bring into the company if you don't already have the skills for the target database. They will have to work closely with the DBA of the source database to map features correctly. The AWS solution architect is not necessarily someone from AWS, but rather an architect who knows how to deploy applications in AWS and is familiar with DMS and SCT. Lastly, the most important people are those who are going to do all the grunt work of changing the database code elements in both the database and the application code. Again, it may be required to bring these skills into your company through hiring or through partners to make sure you are successful. If you are migrating from on-premises and this is your first project in AWS, then you are going to need a new set of skills that will require a combination of developing training plans for existing employees and hiring new talent into the organization. Retraining should be the highest priority, followed by redeployment, and as a last resort, making people redundant if they don't want to change. Based on experience, it is unfortunately better to let people go who don't want to change, or they will slow the migration project by delaying deliverables and being negative. Now that you've completed your application and database assessments, You should have a good idea of which applications will be the easiest and the most difficult to migrate. We recommend that you choose an application that is of medium complexity for a pilot or a proof of concept. This is because you will get overconfident if you choose a simple application and give up if you choose the hardest application. By going for the middle ground, you'll be challenged and learn a lot during the migration. This information can then be applied to the rest of your applications, allowing you to obtain more accurate migration assessments, improve automation, learn the limitations of the migration tools, and understand the dynamics of your team, especially what skills are missing. When people consider the amount performance and integration testing, as you can see on the slide. This is why, as I mentioned previously, you have to treat a database migration project as a complete project. We've covered the database migration tools and how to manage a database migration project. So now I want to move on to the hints and tips that are based on real-world customer experience. The first tip is to use the migration playbooks that are available on the AWS website. These documents explain each major database feature in the source database and how that functionality would be migrated to the target database. As you can see on the slide, here some of the features have green for equivalent functionality, orange for similar but requires some rework, and red for no equivalent capability. If you combine SCT, DMS, and these playbooks, then you're well on your way to having a successful database migration project. A reminder again that you must treat database migrations as a proper IT project. Things will go wrong, so do not expect that you will just run SCT and DMS once. It will be an iterative process as you learn where the issues and bottlenecks are before you can do a production migration. Test all scenarios, including a production test run. We have seen many customers test and dev test or even UAT only to find that their production environments are different and the behavior changed when they tried to do the final migration. Use the native migration methods such as data pump for Oracle, .back files for SQL Server, MySQL dump for MySQL, etc. before using DMS. This is especially true if you're doing a homogeneous migration such as SQL Server to SQL Server or Oracle to Oracle. If you get stuck, then do reach out to AWS for help through support, the online forums, and your AWS account team. There is a lot to go through on this slide, so bear with me. When migrating data with DMS, we have seen many failures across all of these points on the slide. If the source CPU load is too high, there might not be enough capacity to turn on additional capabilities such as supplemental logging or bin log to allow for CDC, let alone during the full load process at the start of the migration that executes select star on each table to be migrated. You need to check if the storage has enough IOPS capacity to handle the increased demands of a migration. You may impact production performance heavily and cause frustrations with your users during the migration if this is not the case. Do you have enough free storage to keep database redo logs for long enough during the migration cycle? For example, it might take 4 days to migrate a 10 terabyte database over your network to AWS before the CDC phase starts. That means you need to keep your redo logs for at least 4 days. What is the redo volume on the database? If this is too high, then you might never be able to catch up on a low bandwidth network. Sometimes batch jobs created a huge amount of redo that can impact the migration, so you might want to plan around those jobs. Will you use the primary, disaster recovery, or replica database for the migration? Each of these has pros and cons that you'll have to evaluate for each source database. If your source database is not patched, you may find bugs relating to CDC support needed for database migration. On the network side of things, you need to check if the right firewall ports are open, that the network throughput is adequate for the time frame you have for the migration, and whether there is any network optimization or routing that will impact the migration. On the AWS side, you need to make sure that DMS instance is right-sized, multiple tasks at once, and matching transaction boundaries between the tasks. If you are targeting RDS or an Aurora instance, then you need to make sure that that is sized correctly too. We recommend that you oversize it for the bulk load process and then resize it before switching the application over to AWS. You should also turn on performance insights and enhanced metrics that will help you understand what is happening in the RDS database and on the instance respectively. One of the big issues we see is security policies getting in the way of migration by blocking access to DMS, RDS, S3 and other AWS resources. So make sure you have the right policies in place. Data validation is critical before making the final cutover. DMS does help you with this, but you may want to do some manual checks. Will it be a big bang approach, use CDC with some testing before cutting over, or even use a load balancer to execute API calls to both on-premises and AWS application stacks for some time before switching over to AWS? You need to make sure you have your backups, HA, DR, performance monitoring, alerts and other operational procedures defined for the new AWS environment too. If you're going to be replicating data continuously, such as with operational systems feeding a data warehouse, then you might want to consider DMS with the multi-AZ option that will keep replication going in the event of a hardware failure or network event in one availability zone. I've touched on some of these points in previous slides, but I want to reinforce that these issues happened at real customers. A network optimizer significantly reduced DMS throughput after a period of time. This was quite difficult to debug as everything seemed to be working fine, but the slowdown didn't make sense. Another one was a network firewall had a rule that dropped long-running database connections, causing a DMS task to fail. A customer had a batch job that caused a huge amount of redo, more than 700 gigabytes over a few hours, and that caused DMS to fall behind by hours given the customer's limited network bandwidth. Data type mappings can sometimes cause problems. Taking Oracle numbers and mapping those directly to Postgres numbers is not efficient. Ints are much better for performance on Postgres. I touched on the sequences and needing to patch source databases on a previous slide, with both of these problems impacting a single customer previously. Many customers look at the name of the database migration service and believe that's all they need to migrate the database. Then they think that DMS doesn't work because there are no foreign keys, indexes, store procedures, and other schema objects after the migration. Remember, always use the SCT and DMS together. I've mentioned IAM and other security issues. These have impacted multiple customers, so do watch out. We have lots of documentation around database migrations, including blog posts, so please read the documentation to save time later on. Lastly, T2 instances are fine for testing, but the production migrations you need to use C4 or R4 instances. T2 instances have CPU credits that will run out, and then the baseline performance will not be high enough for most production migrations. I've mentioned choosing the right instances a few times, so now we'll go through some of the guidelines. AWS offers a large variety of instance types depending on your needs. DMS supports the T2, C4, and R4 instance types today. RDS supports T, M, and R families, with M and R the most common. AWS and Intel have worked together to create or vCPU so that you get the maximum performance for each core that you need to license. R5 instances are the most common instance for serious production database workloads, with a good ratio of 8 gigabytes of RAM for each vCPU, and sizes that start from 2 vCPUs and 16 gigabytes of RAM all the way up to 96 vCPUs with 768 gigabytes of RAM. The Intel CPUs run at 3.1 gigahertz and are therefore cheaper than the Z1D instance that has CPUs running at 4 gigahertz. In this session, we talked about database freedom and how AWS wants to enable you to be able to choose the data store that is best suited for your needs. We talked about some of the core capabilities of SCT and DMS together with some of the recent new features before showing you how SCT and DMS work together during a migration. Then we covered how to manage a migration project and shared hints and tips based on real customer projects. Hopefully you have learned a lot during this session that will enable you to plan your own database migration projects and migrate your databases to AWS. If you are interested in learning more about what I've discussed today, you have several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced courses. Additionally, you can attend our instructor-led classes delivered by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. And finally, remember to validate your technical expertise with AWS certification. We also have a very developed partner ecosystem called AWS Partner Network. With their deep expertise on AWS, APM partners are uniquely positioned to help your organization at any stage of their cloud adoption journey, helping you achieve your business objectives. This brings me to the end of my session. I hope you found it useful. Do remember to complete the survey by visiting the link on the screen today. With that, I would like to thank you for attending AWS.